so let's get underway. I thought what we could do today was a little bit of trig. Okay, so I've chosen this question over here. It's going to be a bit of a challenge, all right, but trig always is. So, but we're going to work through these together, and then we've got a few little problem solving questions that we can try as well later on. We'll get into that. Okay, so question number 5. All right, starts off as follows. It tells us that we have been given that cos theta equals -2 over root 13. And they've told us that theta is an angle between 180 and 360. So what does that mean for us? If cos theta is negative, in which two quadrants is cos theta negative? In which two quadrants could we be working? So if cos theta is negative, in which two quadrants would we be? Okay, so careful, Tyler, because I've got the cos diagram up here. This is quadrant 4. This is quadrant 1. This is quadrant 2. And here's quadrant 3, okay? So where is cos theta negative? That's it, Hayden. Okay, in quadrants 2 and 3. So either we are sitting in quadrant 2 or we are sitting in quadrant 3, but we don't know which one. We can't be in both. So our terminal arm has to come to rest somewhere. So how are we going to work out whether it's quadrant 2 or quadrant 3? Because 180 starts over here, doesn't it? There's 270 over there, and here's 360. So if the angle is between 180 and 360, then it's either in quadrant 3 or in quadrant 4. So the quadrant where we have 2 ticks is quadrant 3, so that's the quadrant that we have to be working in. Does that make sense to everybody? Is that okay, guys? Okay. All right, so we have to draw a diagram, all right, to help us with this question. Even if they don't tell us to, we should draw a diagram. All right, so in other words, what they would expect from us is this. So we're going to sketch the little Cartesian plane. We know that we've come to rest in quadrant number 3. There we go. Here's theta, our angle of inclination. And the other bit of information that they've given us is that cos theta equals -2 over root 13. So cos theta is what over what? What does cos theta mean for us? Cos theta is in terms of x's and y's and r's and that sort of thing. What does cos theta represent? Okay, so it's x over r, absolutely. So that means that we interpret cos theta is -2 over root 13. What are they telling us is the value of x? Okay, so quite right, cos theta is x over r. So the x has to be equal to -2. The r has to be equal to root 13, because remember, what is r? Can r be negative? No, r can't be negative, okay, because it's the length of the terminal r. So r in this case is root 13, positive root 13. And that means that here at the end, our x coordinate is -2. That means our y coordinate is missing. What are we going to use to calculate the y? That's right, it's the hypotenuse. What are we going to use to calculate the y coordinate? There we go. Okay, so calculate the value of y. I'm going to let you guys do that using Pythagoras. Okay. All right, and then you guys can share your answer. Okay, so Boyd Sherpo and Lena, you've both said 3. Okay, and this is where it's so important for us to look at this diagram. All right, what quadrant are we in? We're in quadrant 3. Okay, so that means that both our x and our y are negative. Very, very important. Okay, so this is often where you guys end up losing marks. All right, is on the sign of x or y, because you're not taking cognizance of the fact that you're working in a quadrant where x or y is not positive. Okay, so what we must show here is this. We've got x squared, so -2 squared plus y squared equals root 13 squared. So Pythagoras. And that gives us y squared is equal to, that would be 13 minus 9. Sorry, 13 minus 4. So that means that y squared is equal to 9. So therefore, y is going to be equal to plus or minus the square root of 9. I think that this is such an important step to write down for yourself. Okay, remember when you take square root, your answer could be positive or it could be negative. Okay, so maybe you can write that just as something to help you jog your memory. So therefore, y would be equal to -3. Okay, and then what I like to do here, Matrix, is I like to make myself a summary. All right, so in a different color over here, I write for myself x is equal to -2, y is equal to -3, and r is equal to root 13. And I like to do that so that I have this information to hand when I now want to come along and answer the questions. Okay, so the first question being 5.1.1. So can you see, guys, there's a whole lot of graph that we've needed to do before we can actually get to the answer. All right, maybe not for 5.11, but certainly for 5.12. Okay, so 5.1.1, what are we going to do with sine 90 minus theta? What are we going to do with sine 90 minus theta? Aha, okay. So we've got to remember our co-functions, quite right. So that means that the sine of 90 minus theta is cos theta. Good job. All right, and we know that cos theta is x over r. So in other words, -2 over root 13. So this is out of 2 marks. And the reason that it's out of 2 marks is because 1 mark for the reduction and the other mark for subbing in. Okay, good job. Well done. All right, what are we going to do with 512 matrix? So cos 2 theta, I'm going to write it over here because I'm running out of space. What am I going to do with cos 2 theta? Okay, you're going to expand your double angle, absolutely. You're going to use your double angle formulae, okay? So now you need your double angle formulae. Have you got a formula sheet with you? What are we going to write cos 2 theta as? We've got 3 options. Okay, what I would do here is I would write it as 2 cos squared theta minus 1. And the reason I would do that is because I've already got cos theta. So there's no point me going and working out what sine theta is because I actually don't need it. All right, so to be honest with you here, we actually didn't need to do this. All right, but anyway, we didn't know that before we got started. Okay, never mind. So 2 cos squared theta minus 2. So now we're going to sub in cos theta is minus 2 over root 13. We need to square that and we need to take away 1. Okay, so this is going to give us 2 times 4 over 13 minus 1. So our final answer would be 8 over 13 minus 1, which would be minus 5 over 13 if I am on the correct track here. Okay. All right, is everybody okay with that? All right, so 3 marks here. We have to expand, sub in, and work out our answer. Okay. All right, good stuff. So let's go on with the next question, number 5.2. Unless there are any questions, is everybody fine? Let's just check in with you. Are you all okay? Is 5.1 making sense? Neliswa, could I just ask you just to start 5.2 with everybody? I just need to sort that thing out with my son that I was telling you. I will be 2 seconds and I will be right back.
Okay.
Thank you.
So in the meantime, can you just please do 5.2 while we wait for ma'am to come back? Mohammed, you think 5.2 is class? Oh, that's the one that we're doing. All right. We're gonna wait for the others.
Okay. 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 All right. No problem. Thank you. Okay. All right. Are you guys okay? Sorry, I just have my son arriving home from a school trip and it's just a bit difficult to coordinate everything. Okay, so where were we, Neliswa?
We are doing 5.2 and some of them have posted their answers on the chat.
Oh, wow. Okay. Have you guys done 5.2 or do you need me to go through it? Okay, so you're posting
when you're
answers
done,
over
just
there.
send us your answer.
All right, that's fine. You guys, now be very careful here. You're not allowed to use a calculator to work out the answer. All right, so that means that you have to show all your steps. Did you do that? Okay, because if we use our calculator, we're not going to get any marks. Okay, so you showed your steps. All right, so when we looked at this, we would have seen that it is a cosine compound angle, except it's in the wrong order. All right, so it's sine minus cos. So the steps you would have needed to show is you would have needed to show that you factorized out the negative. That would give you cos 27, cos 33, minus sine 27, sine 33, sorry, 33. Okay. After you've done that, you're going to leave the minus on the outside. Now you can do the reversal of the expansion. Okay, so if you're looking at your formula sheet, remember cos doesn't keep its sign. So that means that we've got to add. So this is going to be the cos of 27 plus 33. That is going to give us the cos of 60. And that's where you're all getting the negative half from. Okay, so in other words, negative 1/2. All right, so there would be a mark for factorizing, a mark for the reversal of the expansion, and a mark for the answer. Okay, all right, so very important when it says without the use of a calculator. We can use the calculator to check, but we have to show all those steps. If we just write down the answer only, they're going to know that we used a calculator, and then we might get nothing. Okay, all right, next one, show that. So equals tan x minus y. Shall we let you guys try this one? And let's see how it goes. So you guys can try 5.3 if we need to. Okay, Boyd Sherpa, you are asking if it's okay to make tan 45.4. Have you finished 5.3 already, Boyd Sherpa?
Ma'am, I got negative cos 42, so I'm wondering how I must represent it in terms of M.
Oh, she's doing 5.4.
Okay, we're not doing 5.4, board shape, we're doing 5.3.
Oh, okay.
Okay, we will do 5.4, but we're doing 5.3 to start off with.
Okay.
That's okay, Cassandra. We're glad you could join us. Okay, so we're busy working on question 5.3, Cassandra. Nelisa and I are just being quiet and we're letting everybody do 5.3 by themselves. And then we'll mark it. If you do finish 5.3 and you're feeling confident with your answer and you want to get started on 5.4, you're very welcome. I will obviously work through 5.3 with you to make sure that all your steps are correct. Oh, wow, can you see that? That's amazing. So have you done 5.3 and 5.4? Can you see there? Wow, that's incredible. How are the rest of you getting on? Are you finished with 5.3? So can you see that just while everybody else is finishing off 5.3, you can have a look at 5.5 in the meantime and start thinking about that. How's everybody else doing with 5.3? Is it going, not going? Okay, so Kalani, you're also done with 5.3. Good job. Where's everybody else? Okay, you're looking at 5.5. Okay, Lena. Done with 5.3. Okay, Kaiser, perfect. All right. Are you guys ready for me to work through 5.3 with you? Okay, so Boy Chepo, you're the only one that's saying yes at this point, but that's fine, doesn't matter. Okay, what I'm going to do is I'm going to leave 5.5 over here. So Kanisile and Lena, if you want to continue looking at it, you can, but I'm going to work through 5.5. Okay, so I'm going to do that here on the side. All right, so the first thing that we notice in the numerator is that we've got two terms. So here is the first term, and here is the second term in green. Okay, so we now want to work with cos 90 minus x times cos y. So cos 90 minus x, what is that going to reduce to? Because it's 90x, 90 plus 90 minus, it means that sine becomes cos and cos becomes sine. Right, so what quadrant are we in? First quadrant. Okay, so that means that cos 90 minus x would reduce to sine x. Okay, cos y doesn't need to reduce, it is already reduced. So we would write that as cos y minus. Now, cos 180 minus x, that's quadrant number 2. Hang on. Yes, so that is going to reduce to negative cos x, like so, and times sine minus y, that is quadrant 4, so that is going to reduce to minus sine. Whoopsie, I'm busy writing the s without the rest of it, and then just the angle. Okay, so that's going to be minus sine y, and that's all over. Then at the denominator, we've also got two terms. All right, so in the denominator, we've got cos x, that's not going to change, so we'll leave it as cos x, times cos y minus 360. Okay, so that's going to put us in quadrant 4, so that would be positive cos y that it would reduce to, minus, okay, now we've got 540 plus x. All right, so if we've got 540 plus x, what we would need to do to the 540 is what, Matrix? What would we do to the 540? We would minus 360, absolutely. All right, so if we minus 360, then we would end up with minus sine, and then this would end up being 180 plus x, like that, wouldn't it? Okay, which would put us into quadrant 3. Okay, so that would reduce to negative sine x, and then that has to be multiplied by sine y. Okay, so that's how we would apply our reduction formulae. What we would have done here is we would have got a mark on the sine x. We would have got a mark on the minus sine y. Then in the denominator, we would have got a mark on the cos y, right? And we would have got a mark on the minus sine x. Okay, so very important when we use our reduction formulae, we have to show what we get as a result of reducing. Okay, very, very important. Now that we've done that, we can sort out some signs, and a negative times a negative is a positive, and whatever the case might be. All right, so in our next line, okay, we're going to end up with sine x cos y. And then here, minus, minus, but then we're multiplying by another negative, all right? So that means that a negative times another negative means it's going to end up being negative, isn't it? Okay, and then here we've got cos x sine y. In the denominator, we're going to end up with plus. Okay, so we're going to have cos x, cos y, plus sine x, sine y. Okay, and now when we look at those, we recognize that in the numerator and in the denominator, we have what sort of angles, matrix? What sort of angles are they at the top and at the bottom? On our formula sheet, they are compound angles, exactly. All right, so the one in the numerator is our sine compound angle. So we're going to do the reversal of the expansion. So that's going to be sine x minus y. At the bottom, we've got our cosine compound angle. Remember, cos does not keep its sign, so this is going to be cos x minus y. And if we've got the sine of x minus y over the cos of x minus y, that gives us the tan of x minus y. Okay, so the next mark over here would be an accuracy on our compound angles. Okay, and then we're obviously not going to get a mark for the answer because the answer is given to us. All right, so let's just check in. How are you feeling? Does that make sense? Did you guys get all those things correct? All right, good stuff. Got it all. All right, lovely, good. Oh, I'm very pleased to hear that. Okay, nice work. Well done, everyone. So question 5.4. Now, I know some people have done it and some people haven't. Can I give you an opportunity to try 5.4 on your own? And Kanisile, have you finished? And Lena, have you finished with 5.5? Okay, I'm glad to hear that you're a little bit stuck, Kanisile. That's fine. It's a problem-solving question, so it is going to be a little bit more difficult. So everybody else, you're trying 5.4. I'll work through that with you as well. Kanisile, you're looking at 5.5. so Kanyisile, I'm going to give you a little bit of a hint. All right. If they want you to determine the value of cos 2 theta in terms of P and Q, have you made P and Q the subject of the formula? Okay. So what did you get P is equal to? The rest of you are working on 5.4. Okay, so just ignore me talking to Kanyisile for a minute. Good. All right. So you've got P is sine theta minus cos theta. Lovely. And what did you get for Q? Can you see there? Okay, so you got sine theta plus cos theta, absolutely. Okay, so now look at cos 2 theta on your formula sheet and look at how it can be expanded. There's 3 ways, aren't there? Okay. So in other words, what you've got over here is you've got P is equal to sine theta minus cos theta. And you have Q is equal to sine theta plus cos theta. On your formula sheet, all right, cos 2 theta is equal to 3 things. Either it's equal to cos squared theta minus sine squared theta, or it's equal to 2 cos squared theta minus 1, or it's equal to 1 minus 2 sine squared theta, isn't it? Okay, so now because we've got a sine theta and a cos theta, we're not going to consider this or this, okay, because our answer is in terms of both. So we're looking carefully at this. How do we create that? Where does it come from? How can we get, so if I say to you, if I want to get x squared minus 9, all right, by multiplying 2 things together, what 2 things would I multiply together to get x squared minus 9? It would be, there we go. So I would need to multiply together difference of 2 squares, wouldn't I? Hint, hint, hint. Yes, can you see it? All right, so I'm going to let you go with that. How's everybody else doing with 5.4? Have we got answers? Or were you guys also looking at 5.5? Yeah, please share what you got for 9 point, I don't know why I keep saying that, 5.4. Okay, should I work through 5.4 with you and then we can come back to 5.5? Is that okay? All right, okay, so let's do that. All right, so the tan of 42, okay? When we talk about the tan of an angle, we're talking about y over x, aren't we? All right, so in this situation over here, they're telling us that y is equal to 1 and x is equal to m. So again, we've got to do the theorem of Pythagoras. So x squared plus y squared equals r squared. So we've got m squared plus 1 squared equals r squared. So that means that r squared is going to be m squared plus 1. Okay, so in other words, r is going to be the square root of m squared plus 1. That's the first thing, okay? So did you get r is equal to root m squared plus 1? Now we've got to use our reduction formulae. So in 5.4.1, we have got to reduce the cos of 222 to an angle using 42. All right, so in other words, what we've got is an angle of 42 degrees over here. At the end, we've got our coordinates, which are m and 1, and we've got r, which is equal to root m squared plus 1. So now we need to reduce 222 to something involving our 42. So we know that 222 can be created by adding 180 and 42 together. So we've got to use our reduction formulae, right? That is quadrant 3. It reduces to negative cos 42. And therefore, our answer is going to be negative x over r. So this is going to be negative m over root m squared plus 1. Okay, did you guys get that as an answer for 5.4.1? Yes. Okay, how about the rest of you? Cool, Lena. Cool, Pochepo. How's everybody else? Making sense? Are we all good? Kulani, good. Indanaso, good. I'm glad. Kashandra, lovely. Thank you. Okay. Nice. Yeah, Tyler, these can be difficult, hey? All right. Trig is not everybody's favorite cup of tea. All right, 5.4.2. Tyler, if you want to reach out to Nelisworth for a little bit of extra assistance, don't be shy. Okay, 5.4.2. Sorry, I'm just mindful of the time here. They've asked us to calculate the sine of 84. So what's the relationship between 42 and 84, guys? Exactly, it's double. All right, absolutely. So now we have to start thinking double angles. So the first thing that we can do, sorry, I'm just going to create a little bit of space down here. In 5.4.2, we have got the sine of 84. So we know that we can expand that using our sine double angle formula. So that would reduce it, would expand to 2 sine 42 cos 42. Does that make sense to everybody? Okay, and now we've got to go back and go and sub in. So we've got 2 times the sine of 42. So sine is y over r. So that's going to be 1 over m squared plus 1. Sorry, 1 over root m squared plus 1, y over r. Okay, then cos 42 is going to be m, which is our x coordinate. Excuse me. Excuse me, sorry, I'm barking here. Over root m squared plus 1. Is that making sense to everyone? Okay. And now we've got to multiply our numerators and our denominators together because that's what we do with fractions. Okay, so 2 times 1 times m is 2m. And at the bottom, root m squared plus 1 times root m squared plus 1 is going to just be m squared plus 1. Okay, and that's what you should have got for 5.4.2. How did that go? Did you get that answer? Well done, Kulani. Well done, Lena. Well done, Kanisile. Good boy, Triple. Yes, Kaiser, your brain is probably a little bit fried at the moment. You're probably in need of a holiday. Okay. All right, so let's do. Oh, how was the matric dance? Was it good, Mr. Bavuma? Oh, good. Nice. Oh, I'm glad to hear that. Okay, well, I tell you what, let's finish off 5.5 and then we can do the poll and we'll call it a day after that since our brains are feeling a little bit fried, which is completely understandable at this time of year. Okay, so Kanyisile and Lena, you had a chance to look at 5.5 before everybody else, and both of you said that you made P and Q the subject of the formula because they wanted us to determine the value of cos 2 theta in terms of P and Q. So it does make sense to write P and Q as the subject of the formula. And then Mohammed, you came up with a really nice suggestion. You said, let's multiply P and Q together, right? Because sine theta minus cos theta times sine theta plus cos theta is difference of 2 squares, isn't it? So this could give us sine theta minus cos theta times sine theta plus cos theta. We would end up doing FOIL, and that would give us sine squared theta minus cos squared theta, wouldn't it? Okay, now how can we relate what we see here that I'm highlighting in yellow? How can we relate it to this? What can we take out of the green?
Take out a negative.
You can take out a negative, absolutely. Okay, so if you take out a negative, you're going to end up with cos squared theta minus sine squared theta. All right, and if we look at our formula sheet, we know that cos squared theta minus sine squared theta is cos 2 theta. So this has to be minus cos 2 theta. Okay, so in terms of P and Q, minus cos 2 theta is equal to PQ. So therefore, cos 2 theta has to be equal to negative PQ. Okay, does that make sense to everybody? Okay, so it's always going to be something that you know. All right, so you have to think about your reduction, not reduction formulae. You always think about your reduction formulae, but you've got to think about your double angles. Okay, so we've looked at, yeah, it does. Hey, so that's problem solving, isn't it? Question 5.5, that's problem solving. All right, let's